All right, so in this Edpuzzle, you are going to learn how to solve equations using logarithms. There are three different types of equations that you are going to be given. So you need to first analyze and then use one of the three methods based on your analysis. Now, notice how it says here, remember that you need to check your answer. I cannot stress that enough because you are going to you might get, not in every equation, but you could get what we had in the past called extraneous solutions, which are what? What are extraneous solutions? Extraneous solutions are solutions that do not work, right? You get it from solving, but it does not work. We had that with square root functions. Why does it not work? Because it's not in your domain. So let's see how that would work. So the first method is drop the base. I don't know why I said like drop the base, which is the same exact method that we had with exponentials. So remember back when we did exponentials, if I have 2 to the x equals 2 to the ninth, what does x equal? X equals 9. You can drop the base, right? Same thing with logarithms is that when you have something that looks like this, so like log base 2 of x minus 4 equals log base 2 of 7. When you have a log equals a log by themselves, you can drop the log. So you get x minus 4 equals 7. And that would be easy, right? So x equals 11. But we have to check our answer before we even box it. So we have to check it. We only need to check one side. If I get 11 minus 4, I can take log base 2 of 7 and it's fine. So it works. If I got log base 2 of negative 3, it wouldn't work because I cannot have a logarithm or a 0 in what? I cannot have a negative number or a 0 inside of a log. Next, let's try this one. Same concept, except what is in our way here? Well, we have a log here by itself. We do not have a log by itself here. We have this 2 here. But we need to get rid of it in order to use this drop the base method. So what do I have to do is I'm going to bring, using my power property, I'm going to bring that 2 up here. And so I get log base 3 of 2x plus 15 is equal to log base 3 of x squared. Now I can drop my base. And so I get 2x plus 15 is equal to what? X squared. What kind of equation is this? This is a quadratic equation. So now I just solve it using my quadratic properties. I'm going to bring these over, factor, and solve. So I'm going to get x squared equals, this will be 0 over here, x squared minus 2x minus 15, right? Because I just subtracted these two over. I'm going to factor, just when you thought you were done factoring. Told you it always come back to haunt you. 0 equals x minus 5x plus 3. And so you get, so that's pretty much done. So you get x is equal to what? 5 and negative 3. But let's check our work. So I'm going to check it for both of these from our original problem. So I have log base 3 of 2 times 5 plus 15 equals 2 log of 5. And really we're going to go all the way through. So it's going to be 2 times 5 is 10 plus 15. So log of 25 is equal to 2 log of 5, which we know is true because if we brought that 2 up, it would become 5 squared, which is 25. But the point here is that it doesn't give you a red flag, which is a negative or a 0 inside. So that's fine. So we try the next one. So log base 3 of 2 times negative 3 plus 15 equals 2 log of negative 3. And so you get log base 3 of negative 6 plus 15, which is 9, equals exactly this, right? 2 log of negative 3. What's the red flag here? You cannot have a negative inside of a log, big red flag. So this cannot be your solution. So your only solution is x equals 5. Because this means that it is extraneous. Extraneous solution is x equals negative 3. So that's the first method. First method is solving by dropping the log. Next method is what I put here is change to exponential form. Okay, so we have this right here. I'm only doing one because we've done problems like this already, where you have something in logarithmic form, and this is really what you're going to want to use if you have an x inside of your logarithm. If you have an x anywhere else, actually, or as your base, but that's usually not the case, you're usually either going to have a variable here or here. If your variable's inside of the log, it's going to help you to change it back to exponential form. So 36 to the 3 halves is equal to x. So let's do that. 36 to the 3 over 2 power is equal to x, and then we just evaluate this. And remember, taking something to the 1/2 power is the same thing as taking the square root. So we have 36, the square root of 36 is 6 cubed, and 6 cubed is, I'm forgetting off the top of my head, 36 times 6, I'll pause and come back. All right, it's 216. So we get x is equal to 216, and if we check our answer, just if we were to plug it into here, it doesn't violate any of the log rules because it would still be a positive number inside of your logarithm. And last but not least, the last method is called, I just told you what to do, right? Drop the log, change to exponential form, and then change to logarithmic form. And this is if your variable is in your exponent. And this is where the change of base formula is going to be very, very useful. So if you look at something like this, 3 to the x equals 32. Now, before we even do this, I'm going to tell you this. When we get on to the next video, which is modeling, which is word problems, this is the method that's going to be the most useful, because this is solving exponential equations for your exponent. And this was kind of the whole point of logarithms to begin with, was to solve for exponents. So this is really, really, really essential for you to grasp. When we are doing this, we are going to change it to logarithmic form. So we have log base 3 of 32 is equal to x. And now we can use the change of base formula. And I'll even change this over here. I'll put x equals. X equals log base 3 of 32. And so that I know is x is equal to log of 32 over log of 3. And then you just use a calculator and you can come back and do this. So I know from my calculator work that it's 3.15. Now I know that this is true because 3 cubed is 27, so it has to be a little bit more than 3. So 3 to the 3.15 is 32. And so x equals 3.15. And this is an exponential equation that we are using logarithms to solve. So there is no domain restriction when it comes to exponentials, because the domain of exponentials is all real numbers. So you can check it just to make sure your answer is right. But when you're talking about exponential equations, you are simply using logarithms versus actually having an exponential equation. It's like having a quadratic and using square roots to solve it versus having a square root function itself. All right, and let's try this last one. Same exact thing, the variables in your exponent, so you're going to change it to logarithmic form, and so it's going to be log base 6 of 135 is equal to x plus 1. And now you still need to solve for x, but I would do this first. It doesn't matter. It literally doesn't matter. You could bring the minus 1 over first, or you can do the change of base formula first. It does not make a difference. I'm going to do the change of base formula first. So I'm going to have log, or you know what, let's switch it up a little bit and do natural log. Because it does not matter which one you use, you're just going to want to use 10 or e because it makes it easier to use for the calculator. So natural log of 135 over the natural log of 6 equals x plus 1. When I put that in my calculator, I get natural log of 135 divided by the natural log of 6 is equal to 2.74 approximately equals x plus 1, and then you solve for x. So I just subtract 1 from both sides. So what do I get? I get x is equal to, not 3, 1.74. I just subtracted 1 from this. And there you go. There's your answer.